Welcome to the project demonstration of safety helmet system for coal miners by using Arduino Uno and zigbee. Here we are using 4 different sensors for data transmission and 5th sensor for alerting to the coal miner. So in that 4 sensors are gas sensor and a smoke sensor and CO sensor and a humidity temperature purpose DHT11. So these 5 parameters continuously monitored and send the alerts related to the sensors through the zigbee, and the receiver will receive the data and it will be displayed on the alert message on the LCD screen along with audible alert buzzer. So in the transmitter section we are interfaced these sensors to the Arduino Uno board, and receiver section we have interfaced the zigbee and buzzer LCD to PIC16F72 microcontroller. And the helmet section consists of battery operated and which is rechargeable battery, and here using 3 4-volt 1 amp batteries. These 3 are in series, so we will get 12-volt 1 amp DC output. But the operating voltage for our microcontroller Arduino board and sensors is 5 volt. For that purpose, we are using LM2596 voltage regulator. From there, we are going to get the 5 volts constant DC outputs when we provide that to the breadboard. So here we are using the breadboard to distribute the 5 volts power supply throughout the input and output modules. Once we provide the 5 volts here, all the modules will get the power supply. Especially Arduino Nano start reading input from the input sensors, and it will control the output modules like buzzer and LED indications. So here we have attached the LEDs, 3 LED indications. The respective sensors, the respective LEDs will get switched on, and the output module is zigbee and buzzer. So here coming to this receiver section, zigbee and is the input module and output module buzzer and LCD display. So let me show you the recharge section procedure for this battery. So they will provide the 2 pin, and this is the battery charging section. Connection pin, connect the at this slot only. So here we will write the B and B. Right. Connect the B at the battery slot, T for the transformer slot. Then on the power supply to the transformer. As we are using the timing based charger, now when we provide the 230 volts AC input to the transformer, so it will step down that to 12 volts 12 volts AC, and this regular power supply will convert the AC to DC. So it will get fully charged in a duration of 6 to 8 hours. Once the time completes, automatically these diodes will block the current flow from the charging section to the battery when the battery is getting fully charged, in order to protect the battery from overcharging. After that, we can switch off the power supply to the transformer and keep the charger aside. So before on the gate, the very first step is we should keep the battery under fully charged. And let me explain you the connections. So we have interfaced the DHT11 at pin number 10, and a gas sensor connected at the pin number A2, A1 for the CO sensor. This is CO we are using, and smoke for the A0, and the LEDs which are related to the respective output of the sensors. LED for the gas sensor is 5th pin, 6th pin for CO, 7th pin for the smoke sensor, and buzzer at 13th pin, and IR sensor at pin number 11, and zigbee connected to 0 and 1 hardware transmitting receiving pin of our Uno board. And coming to the receiver section, pin number B2 to B7 LCD, zigbee at B01, and next buzzer at C3 is connections. Let us see the demonstration. While we demonstrate, we should take care of the external sunlight should not fall on this IR sensor while we demonstration, otherwise it will provide as a malfunctioning. Right. So now on the power supply, as we can see, the sunlight is falling on the IR sensor, so the second light is continuously on. Now it is normal. So on the power supply for the receiver module also. Here we can see the welcome message on the LCD display, and in normal monitoring message will be displayed on the LCD. So if the obstacle detected, the only buzzer alert will given for the coal miner as alerting of obstacle was there at the head level. And the next, smoke sensor inputs. So you can see the same smoke alert message displayed on the LCD at the receiver section also. And the next, coming to the CO, So as you're using the permanent marker for demonstration, as it has the so you can see the CO alert message on this one. And the next, gas. So humidity is we need to blow the hot air at the humidity sensor, then the humidity will increases, then you will get the audible alert just like at the transmitting and receiver section. So let me show you the LED section also. So whenever the respective sensor provides us the abnormal data, so green light for the LPG gas. So yellow light for the CO, and the green light is going to be the smoke sensor.